Welcome to all. Myself Karthik, Assistant Professor of AC Department, SRM Madurai College for Engineering and Technology. Today we discuss about the subject Networks and Security. The topic name Networks Models, OSI and TCP IP Protocols. The ISO was established in 1947 to develop international standards. The ISO standard covering all aspects of the network communication. The OSI model introduced in the 1970s later. So the 7 layers of OSI models it shows. This is the 7 OSI model layers, starting from the number 1 physical layer, number 2 data link layer, number 3 network layer, number 4 transport layer, number 5 is the session layer, number 6 presentation layer, and 7 is the application layer. The 7 layers major role play in the OSI models. It shows a figure, the device A and device B. The device A and device B is a system. The messages traveling from device A to device B may pass through the multiple intermediate nodes, which typically involve only the first 3 layers, the physical layer, data link layer, and a network layer. The OSI model was designated as addressing the data transmission process into fundamental elements grouping related to the functions in discrete layers. Each layer performs distinct functions, do not overlap the layers. Within the single machine, each layer lays on the services of the layer directly below. It provides the services to the layer above it. Between the machines, the communication happens in the same layer. For example, the layer X on the one machine communicates with layer X on the another machine it receives. This is the peer-to-peer communications protocols define the rules and data exchanges. The physical layer enables direct communication, transmitting a stream of bits from device A to device B through intermediate nodes. It's highly layers flow a layered process where data moves down through the layers on the sending device across the network and up for the layers on the receiving device. On the sending device, it's own information to the message received from the layer above. The layer 1 converts the message unwrapped layer by layer. The layer 2 extracts its data and to forward to the layer 3, and the layer 3 it's forward to the application is the higher rank. So it is the principle for every layers. The 7 layers can be categorized into 3 groups: the physical layer, data link layer, network layer. This layer handles the physical transmission of data, including the electrical specifications and physical connections and addressing and transport timing and reliability also. User support layers, the layers 5 to 7, the session layer and presentation layer and application layer. These layers entire interoperability between the different software systems. The layer 4 of the transport layer, the bridge between the two groups, ensuring the data transmitted by the lower layers into the format usable by the upper layers. This figure shows the physical layer. Normally, the physical layer is responsible for coordinating functions required a transmit bit stream in the physical medium. So the from the data link layer and comes from the physical layer to transmission medium, and the transmission medium to again physical layer, the physical layer from out from the to data link layer. It handles the mechanical electrical specifications of the interference and the transmission medium. The layer defines the procedures and functions necessary for physical devices interference to facilitate the data transmission. Its figure, the physical layer position, it relationship to the data link layer to the transmission medium. Next one is the data link layer. The data link layer converts to the physical layer, for example, the raw transmission medium into reliable link. It ensures that the physical layer appears error-free to the upper layer. This layer is responsible for the error detection and corrections. This figure shows the relationship of the data link layer to both network layer and physical layer. Next one, network layer. The network layer is responsible for source to destination delivery of packets, even across the multiple networks. It ensures that each packet travels from its origin into the final destination. The difference between the data link layer messages packet delivery between the two systems on the same network. The network layer is needed when two systems are on different network requiring intermediate devices for connectivity. If two systems are on the same network, the network layer may not be needed. When systems are in different networks, the network layer is required to enable end-to-end delivery. So the figure shows the network layer position in the relationship between the data link layer and the transport layer. Next one is the transport layer. The figure shows the transport layer is responsible for process to process delivery of the entire message. This process refers on the application program running on the host. The difference from the network layer ensures the source to destination delivery of and individual packets, but it treats them independently without recognizing their relationships. The transport layer ensures that the entire message arrives in order. The transport layer provides error control. It ensures error-free transmission of the message, and flow control. It manages the data transmission rate to the prevent congestion. So its figure shows the relationship with the network layer and session layer. Next one, this is the session layer. The session layer, it provides the first three layers. The number one is the physical layer, next one is the data link layer, and the network layer are not sufficient for some process. The session layer, the layer of file, act as a network dialog controller. It is responsible for establishing, maintaining, and synchronizing communication between the interacting systems. The session layer ensures proper dialog control, preventing the data overlap or loss in the long duration communications. Next one, this is the presentation layer. The presentation layer, it handles the syntax and the semantics of data exchange between the two systems, and it ensures the data is formatted, translated, encrypted, or compressed as needed to the proper interpretation. Its responsibilities of the presentation layer include data transmission, encryption, decryption, and compression and decompression. So it shows the figure, the presentation layer relationship with the application layer and session layer. Next one is the application layer. The application layer, it allows users to access the network. It provides the user interfaces and supports various network uses. For example, electronic mail, remote file access and transfer, and shared database management, distributed information services, etc. The illustrates the applications layer's relationship with the user and the presentation layer. The more than application layer example, the x.400 and the x.500. The x.500 it means that the directory services and the file transfer access and management. Shortly in terms of FTAM, it manages the file and sharing operations. Next, this is the summary of the layers. So the all layers presented in this figure. Next one, the TCP IP protocols. The TCP IP protocol was developed OSI model. Their layers do not match exactly. The original TCP IP model had 4 layers only. The host to network, then internet and the transport and applications. When compared the OSI model, the layers can be mapped as follows. The first one, the host to network layers corresponds to both the number one layer, physical layer, and number two is the data link layer. The internet layer, its correspondence to network layer number 3. The transport layer remains the same in both models of transport layer number 4. The application layer TCP/IP combines the functions of the OSIs, the layer number 5 session layer, and the layer number 6 the presentation layer, and the last one is the application layer is the layer 7. The TCP/IP is considered to have a 5 layers: the physical, data link, network, transport, and applications. The first 4 layers of TCP/IP provide physical standards, network interference, and internet working and transport functions similar to the first four layers. The the next level of three top OSI layers are combined into single application layer. Its figure shows the 2.16, the TCP/IP hierarchical meaning. The each upper level protocol is supported by one or more lower level protocols. The protocols are modular and relatively independent. The key protocols of TCP/IP at the transport layer. The TCP is a reliable connection-oriented protocol, and this is the UDP is a user datagram protocol, the lightweighted and connectionless protocol, and SCTP it's a stream controlled transmission protocol. It is used for the multimedia and signaling applications. At the network layer, the Internet Protocol IP, the primary protocols of the addressing and routing packets. Other supporting protocols assist with data movement in this layer. This is the TCP/IP protocol suites. Okay, this is the OSI models major role play in the network security. Thank you.